Welcome. Today we'll start new chapter Bode plot. Bode plot means this is the graph which consists of magnitude plot and phase angle plot. Bode plot is plotted on semi-log paper. Semi-log paper means x-axis, semi means half, log paper. Therefore, half scale on the graph paper is logarithmic scale and half scale will be of regular scale. Therefore, x-axis is divided into logarithmic scale and y-axis is divided into a regular scale, regular type of graph. X-axis is into logarithmic scale. Therefore, that is known as Bode plot. Therefore, we will see now syllabus, magnitude and phase angle plots, standard form of open loop transfer function g of j omega h of j omega, Bode plots for standard factors of g of j omega h of j omega, steps to sketch Bode plots for following factors: system gain k, poles and zeros at the origin, simple poles and simple zeros, frequency response specifications, calculation of gain margin and phase margin from Bode plots. Therefore, this is the syllabus. First of all, we will see the theory and in next lecture we will see the problems. Now, introduction. Stability of control system plays an important role in all modern control systems. Stability of measurement decides the accuracy of measurement. The stability of control system can be predicted by using either Routh's array method or root locus or Bode plots. Therefore, there are three methods to decide the stability of the control system. First is Routh's array method, second is root locus method, and third is Bode plots. Therefore, Bode plot is a graphical method to predict the stability of system which consists of two plots. First is magnitude m expressed in logarithmic values against logarithmic values of frequency called as magnitude plots. Second, phase angle against logarithmic values of frequency called as phase angle plot. These graphs are plotted on semi-log paper which is used to sketch the magnitude in dB, that is decibels, and phase angle in degrees against log of omega. For this, logarithmic scale is used which is available on semi-log papers. In such papers, the x-axis is divided into a logarithmic scales which is non-linear, while y-axis is divided into linear scale. Hence, it is called as semi-log paper. Now, next point, magnitude plot and phase angle plots. The magnitude can be expressed in its logarithmic values by finding out the value 20 log of g mod of g of j omega to the base 10, which has a unit as decibel denoted by dB. For Bode plots, mod of g of j omega is equal to 20 log of mod of g of j omega to the base 10 in decibels. Such decibel values are to be plotted against log of omega to the base 10. In phase angle plot, angle of g of j omega is to be expressed in degrees, which is to be plotted against log of omega. As for both plots, x-axis is log of omega, both may be drawn on the same paper with common x-axis. Now, next point, standard form of open loop transfer function g of j omega h of j omega. Consider GSHS is equal to k dash into s raised to z into s plus z1 into s plus z2 plus into dot dot dot. divided by s raised to p into s plus p1 into s plus p2 dash dash dash. Note that either s raised to z or s raised to p will be present at a time and not both. This form is not useful to draw Bode plots, hence it is necessary to rewrite the GSHS in time constant form. Therefore, time constant form of GSHS is equal to s raised to z into k into 1 plus t1s into 1 plus t2s into dot 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 divided by s raised to p into bracket 1 plus tas into 1 plus tbs into dot dot dot, where k is equal to z1 z2 dot 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 into k dash divided by p1 p2 dot 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 infinity. Again, either s raised to z or s raised to p is present and not both. S raised to p is known as pole at origin, s raised to z is known as 0 at origin, 1 plus t1s is known as simple 0, 1 plus tas is known as simple pole. Therefore, the standard time constant form can be denoted as GSHS is equal to k into bracket 1 plus t1s plus into 1 plus t2s divided by s raised to p into 1 plus tas into 1 plus tbs. Equation A, where g of j omega substitute s is equal to j omega. Therefore, g of j omega into h of j omega is equal to k into bracket 1 plus t1 of t1 into j omega into 1 plus t2 j omega divided by j omega raised to p into 1 plus ta j omega into 1 plus tb j omega. Now, steps to draw magnitude and phase angle plots. The stability of control system can be predicted by knowing the values of gain margin, that is GM, and phase margin PM, from which the magnitude and phase angle plot should be drawn. The procedure to draw the same is listed as below. First, step 1, convert given equation into time constant form. For example, consider this equation: GSHS is equal to 20 into bracket 1 plus s divided by s plus 2 into s plus 5. Therefore, how to convert this equation to time constant form? Here, that one term should be there in the bracket, one term should be there. Therefore, GHS is equal to 20 into bracket 1 plus s. Here already 1 plus s term is there. Therefore, no need to take anything outside common. Divided by, now here s plus 2 is there. We want s plus 1. Therefore, what we have to do? We have to take 2 outside. Therefore, we have taken 2 outside into bracket 1 plus s by 2. Now here s plus 5 is there. What we want? 1 plus s. Therefore, we have to take 5 outside. Therefore, 5 into 1 plus s divided by 5. Therefore, which is equal to 2 into 1 plus s divided by 1 plus 0.5s into 1 plus 0.2s. This is known as time constant form. Step 2. Evaluate general information of the system. General information in that first is evaluate magnitude of steady state gain of the system, that is magnitude of g of j omega into h of j omega. Let g of s into h of s is equal to 2 into bracket s plus 1 divided by 1 plus 0.5s into 1 plus 0.2s. Here k is equal to 2. After comparing with standard equation A, we can write 20 log of k to the base 10 is equal to 20 log of 2 to the base 10, which is equal to 6.02 dB. Gain of system k remains constant for any variation in omega from 0 to infinity. Therefore, gain always remains constant, always remember. Now, evaluate number of poles at origin. Let GSHS is equal to 1 divided by s. Therefore, GHS is equal to 1 upon s, or pole at origin. Replace s by j omega. Therefore, g of s into h of s is equal to 1 upon j omega. Therefore, which is equal to 1 plus 0 plus j omega is equal to 1 divided by square root of 0 square plus omega square. which is equal to 1 divided by square root of omega square, which is equal to 1 upon omega, which is equal to omega raised to minus 1. Therefore, g of j omega into h of j omega is equal to 20 log of omega raised to minus 1 to the base 10, which is equal to minus 20 log of omega. That is, slope is equal to minus 20 dB. Therefore, one single pole contributes to minus 20 dB of slope. Therefore, two poles at origin will contribute to minus 20 into 2, therefore minus 40 dB of slope. Similarly, 3 poles at origin contributes to minus 20 into 3, which is equal to minus 60 dB of slope. Now, zeros at origin. Consider this equation: 20s divided by s plus 1 into s plus 2. Now, the term s in the numerator, that is known as 0 at origin. Therefore, replace s by j omega. Therefore, g of j omega into h of j omega is equal to 20 j omega divided by 1 plus j omega into 2 plus j omega. 1 0 at origin is equal to 0 plus j omega, which is equal to square root of 0 square plus omega square, which is equal to omega. Therefore, mod of g of j omega into h of j omega is equal to 20 log of omega to the base 10, which is equal to 20 dB. Therefore, you can say that slope is equal to plus 20 dB per decade. So, one single zero or single zero at origin contributes to plus 20 dB slope. Therefore, two zeros will contribute to 20 into 2, that is plus 40 dB of slope. 3 zeros contributes to 20 into 3, which is equal to 60 dB of slope. 60 dB per decade, 40 dB per decade, 20 dB per decade. What is meant by decade? While solving examples, I will tell. Now, analysis of simple pole. For example, let 20s divided by 1 s plus 1 into s plus 2. Therefore, simple pole is nothing but here 1 upon s plus 1. Comparing with standard form, that therefore 1 divided by 1 plus s is equal to 1 plus 1 divided by 1 plus tau d. Therefore, tau is equal to 1. Therefore, corner angular velocity omega c1 is equal to 1 divided by tau is equal to 1 divided by 1 is equal to 1 radian per second. For 1 divided by s plus 2, which is equal to 1 divided by 2 plus s. Therefore, 1 plus 1 divided by 1 plus tau d is equal to 1 divided by 1 plus 0.5 s. Therefore, tau is equal to 1 by 2 or 0.5, and omega c2 is equal to 1 divided by tau is equal to 1 divided by 1 by 2, which is equal to 2 radian per second. So, simple pole contributes minus 20 dB of slope. Slope of resultant magnitude plot and changes at corner frequency omega. If corner frequency omega c is due to simple pole, slope of resultant plot increases by minus 20 dB after corner frequency. Now, analysis of simple zeros. Simple zero contributes plus 20 dB of slope. Slope of resultant magnitude plot changes at corner frequency omega. If the corner frequency is due to simple zero, slope of resultant magnitude plot decreases by 20 dB. Always remember, if simple pole is there, slope increases by minus 20 dB. If it is simple zero, it is decreases by plus 20 dB. Step 3. Based on above analysis, plot magnitude graph with proper scale. Now, step 4. Analysis of angle plot or phase angle plot. In that, now, A point. If system has single pole at origin, it contributes to minus 90 degree to phase angle plot. If system has two poles at origin, it contributes to minus 180 degree to phase angle plot. If system has single zero at origin, it contributes to plus 90 degree to phase angle plot. If system has two zeros at origin, it contributes to plus 180 degree to phase angle plot. And fifth, that is E. If system has a simple pole, it contributes to minus tan inverse of omega t. and if system has simple 0, it contributes to plus tan inverse of omega t. Always remember, for simple pole minus tan inverse of omega t, for simple 0 plus tan inverse of omega t. Now next step, plot phase angle curve with resultant values of phase angle. Now this is the end of the theory. While solving problem you will understand. Therefore in next lecture we will see how to solve problems of Bode plot. Please bring semi-log paper. I will explain semi-log paper while solving problem itself. Thank you very much.